Okay, so we will look at these 5 different topics: binary logistic regression, canonical correlations, exploratory effect analyses, confirmatory effect analysis, and structural equation modeling. All right, so these are the 5 topics we will cover, and therefore there are 5 assignments, each assignment for each module. And as a rule of thumb, you should be able to turn in or submit the assignments within 2 weeks after completion of learning the module. So I think if you keep that as a rule of thumb for turning assignments, you really shouldn't have any problem, being behind by the end of the semester. There is a class project which we forego last semester, but I think we need to have a class project this semester. And the class project is really think of the class project as a capstone activity that would require you to comprehensively apply one or more of these different techniques. All right. And then I think by April 21, I don't know exactly when the grades is due, but certainly by the end of April, I think all of your assignments need to be completed. Okay. At which time I should turn in grades. Okay. Questions? All right. So it's really important that you have the software, both SPSS and Amos. We will start using Amos by about the beginning of March. So that's when we will be using Amos to do confirmatory effect analysis. Until then, we'll be using SPSS. And I was told towards the end of last year that both SPSS or that NCU now have licenses for both SPSS and Amos. And so you should be able to get those. I think Sally said she has her software SPSS and Amos working. The rest of you, if you don't have your software working yet, you need to get in touch with Sally so she can tell you what she did to get her software working. All right. Questions? All right, everything clear so far? Okay. So what I want to do today to begin is to look at binary logistic regressions. Sally, can you open up your SPSS?
Okay.
And make sure you have binary logistic regressions.
It's loading, so give me a minute.
Okay.
And I'm looking for binary.
Okay, can you share your screen so I can see what you're doing? So we can see what you're doing?
Do I have the option to share screen?
Yeah, you should have, I just made you co-host, so you should, at the bottom middle of your screen, you should have something called share
Okay.
screen.
Mm-hmm.
Okay, so can you go to analyze?
Uh-huh.
Okay, click on that and go to regressions. Okay, good. You've got binary logistic
Binary
regression.
logistic, yeah.
Yep. Okay, good. I just want to make sure that you have the software to do that, because otherwise no point. Okay, go to analyze again. I want to make sure that you've got canonical correlation. Go to correlate,
Mm-hmm.
and you have canonical correlation. Good.
Yes.
All right. So you have the software to do all of that. All right. Go ahead and unshare your screen.
Okay. Mm.
Okay. So if you are downloading, or if you're going to be using the software that NCU has, which which presumably is the same as what Sally has. So you do have the software to do binary logistic regressions as well as canonical correlations. So I think you are, I think we are on the right track. Okay. All right, let me share my screen. Okay. So this is the data set that you are familiar with. You've done this, we used this data set in last semester in Psych 701. Yeah. In that class, we did multiple regression analyses in which we had this. Okay. So we had, this is your dependent variable, okay, and we stipulated that in multiple regression analyses, that this dependent variable is continuous, okay, or it is scale variable with predictor variables also as continuous. So all of these are continuous variable or scale variables. That's the stipulation we, or that's the, yeah, that's the constraints that we looked at multiple regression analyses yeah, last semester. I also said to you that that you can do multiple regression analyses with mixtures of categorical and scale variables. In other words, you can have a continuous variable and you have mixtures of independent variables that are categorical and scale variables. Okay. So it is possible to do that. And so in that sense, we will use something called categorical regression analysis. Okay. What we will attempt to learn now under binary logistic regressions is when we have a dependent variable that is binary. That means it has only two values, zeros and one. Okay. Categorical, binary, fail, male, female, successful, failed, suicide, not suicide, sexually abused, not sexually abused. All right. So in binary logistic regressions, we will be looking at dependent variables that are dichotomous in value, binary in values. That means it has only two values, yes, no. Okay. All right. And then we want to use predictors that are combination of categorical and scaled independent variables. In other words, we will be using regression analysis, using predictors that are categorical and scaled or continuous, but the dependent variable will always be dichotomous, yeah, zeros and ones. Okay, so let's look at scenarios, research scenarios where you might look at this. Okay. So let's say that you have several variables, and let's say you just want to look at gender differences. Okay, where female is 0 and male is 1. So this is your dependent variables. In other words, you want to determine if there are gender differences on a number of variables that are both categorical and continuous. Okay. So for example, let's say the independent variables. In other words, let's say we want to see if there are differences between male and female on let's say whether or not they have attempted suicide versus not attempted. Okay, so that's one. So if this is all, okay, if this is all that you have, in other words, if you want to determine if there are gender differences in terms of whether they attempted suicide versus not attempted suicide, what analyses strategies would you use to do this? You learn this in your beginning stat. How will you determine if there are gender differences in whether or not there is differences in suicide attempts? So recall your stat before 701. How will you analyze this data to determine gender differences in the proportion of people who attempt suicide? Any thoughts? See, this is the kind of thing that you are going to be asked.
Doc, does it have anything to do with the T-score value of the?
Was that?
Does it have anything to do with the T-score value of the?
T?
Of the,
are you talking about T?
yeah.
Well, would T statistics be appropriate in this case?
T or the Z-score, one of them. I don't know, that just flashed through my head right now.
Okay. See, this is the kind of things that you are going to be asked. And that is, you know, colleagues of yours are going to ask you and say, I've got this research situation. How should you, what statistical procedure would I need to analyze this data? So if somebody comes along and say, this is what I want to do, then you should be able to tell them the appropriate statistics is, in fact, the chi-square test of associations or chi-square test of independence. That's the appropriate test you need to do, right? And the reason for that is both your variables are categorical. So gender is zeros and one, okay? Suicide attempt is no attempt versus attempt. So both of these are categorical. So if you want to determine gender differences on these, the appropriate test statistics is chi-square. Okay. Now, if you were to look at gender differences, okay, on some continuous variable, let's say GPA, GPA would be considered as continuous or scaled, then you would use the t-test for independent samples or the independent sample c-test. Yeah. So you would have had to use, to determine if there are gender differences, you would use the chi-square. Yeah. Now, so, but then let's say you have gender, yeah, zeros and one, and then you have, this is your dependent variable, okay? And independent variables are, let's say suicide, which is zeros and one, and let's say and another independent variable is at risk behavior, which is scaled, continuous. Okay, so let's say that we want to do a regression analysis to determine gender differences in terms of suicide attempt and at-risk behavior, okay, which is scaled. If you look at this univariately, then you would use chi-square here. And if this is your again, this one scale, you would use your independent sample t-test. But how would you go about using, these two variables at the same time? Okay. That's where binary logistic regression comes in. And that is, in binary logistic regressions, you can combine dependent, categorical variables and continuous variables together as predictor variables. All right, so that's the advantage. The other advantage of binary logistic regressions is that it really doesn't care what shape the distribution is of your variables. Okay. It doesn't matter whether it's skewed or normally distributed. It really doesn't care. Yeah. So logistic regressions is a technique that has been classified as assumption-free or distribution-free statistics. It has basically no assumptions. Well, actually, there's only one basic assumption, is that there should be at least some linear relationship between independent and dependent variables. That's really the only assumptions in binary or multinomial logistic regressions. So, and that's why, logistic regression is used quite often or very popularly used in, in healthcare settings. Because in healthcare settings, the distribution of health variables are rarely normally distributed. Okay, and a lot of times they are categorical in nature. So logistic regression is widely used in in a health, in the health sciences. Yeah. But we also do this in social sciences because, again, many social science variables are not always normally distributed and not always scaled. Okay. So, so how do we go about using binary logistic regressions? Again, we will limit our learning of logistic regressions to binary logistic regression, meaning the dependent variable has only two values, zeros and ones. Okay. There is something called multinomial logistic regressions in which the dependent variable can have more than just two categories. You could have 0, 1, 2, 3. You can have 4 categories, 3 categories, 5 categories. Okay, that would be multinomial logistic regressions. But in this class, we will only look at binary logistic regressions. Okay, in other words, we will limit our learning of logistic regressions to binary logistic regressions in which the dependent variable is has only two values. All right. Any questions so far? Okay, let's begin illustrating binary logistic regressions. And we will begin with one predictor, one dependent variable, okay, a dependent variable that's binary, and one predictor variables. Yeah. In this value 2 data that you are familiar with now, we want to determine suicide attempts. Okay, we want to explain suicide attempts. In other words, why we want to determine what explains suicide versus no suicide. So in this data set, I created a binary suicide group in which 0 is no suicide and 1 is suicide. In other words, what explains, or what would be some of the variables that would explain why students attempt suicide. All right. Now, as in multiple regression analyses, we want to make sure that our independent variables, in fact, do explain suicide attempts. Yeah, this is our dependent variable. Suicide versus non-suicide. In other words, you have to conceptually make sure that the variables, your independent variables, whether it's categorical or continuous, yeah, would be related to the dependent variable. Okay, just like multiple regression analysis, in selecting your independent variable or your predictor variables, you want to make sure that your predictor variables or independent variables, in fact, do theoretically explain suicide. Okay, so if you were to choose height, as a predictor variables to suicide, that probably will not make sense, right? Okay. So choosing height to predict suicide attempt probably will not make theoretical sense. Okay. Whereas weight might. Oh, then you can say, yeah, but weight might be height, weight might be related to height. I mean, people who are tall are going to be heavier. But when I say weight, maybe what we want to do is instead of weight, we might want to look at in terms of obesity, right? And then when we talk about all of these, we might then consider eating disorder. Yeah. So in other words, we want to make sure that the predictor variables, the variables, our independent variables, in fact, do explain suicide attempts. Okay. So let's say, excuse me. So let's say that one of the reasons why students attempt suicide is because they have been sexually abused. Okay. So let's say that conceptually, one of the reason, and then you can use the literature to sort of back this up, and that is one of the reason why students, young adolescents attempt suicide is because of sexual abuse. Yeah. So one of the things that we can then do is, can we predict suicide attempt based on sexual abuse, right? So to do this, we can do then binary logistic regressions. So to do binary logistic regressions, you were to analyze regressions and linear. Notice we are not doing any assumption testing. We're not checking for normality. We're not checking for the other stuff because there really isn't assumptions to binary logistic regressions. Yeah. So analyze regressions, binary logistic. Okay. So we go binary logistic regressions and so the dependent variable here is suicide group. And let's begin with one predictor, which is sex abuse group. Okay. So notice what we are doing here. It's we are using sexual abuse as a predictor of suicide attempts. Yeah. So the next thing we want to do is go to options. Okay. So to do this, let's go to Hosmer, Lemonshire, goodness of fit. And let's do confidence interval. All right, can click continue. And can go categorical. We don't need to do that. We can do save. We can look at Cook's distances. We can look for outliers. So we don't need to do that. Yeah. So all we need to do now is click OK. All right, so this is the result we have. Okay, so the suicide group, okay, this is classification predicted. There is, you know, the actual, this is the observed. So here 355 have attempted suicide, 1927 did not attempt suicide. All right. Now you remember how we evaluated goodness of fit, meaning how good is the equations. All right, how good is the equations? So here is the regression equation, the logistic regression equations right here. So this really is the meat of this is really the meat of the binary logistic regressions. Okay. All right. And so if you remember your multiple regression analysis, you have the regression coefficient, you've got the standard error. Instead of standardized regression coefficient, you have the wall statistics here, and we'll talk about what those are a little later on. But you do have the p-value, and then there's something new here called this is the exponential of b. This is what we call as the odds ratio. This is called the odds ratio. What the odds ratio, and that's very important because that's what you interpret. Okay, the odds ratio has to do with the likelihood of one variable occurring for each group of your dependent variable. Yeah. And I will sort of explain this in a little bit. Yeah. So those are the kinds of things that we're going to look at. The other thing that very similar to what we did in the multiple regression analysis is the R-square, right? Remember, in the multiple regression analysis, one of the way to determine how good your prediction model is to look at R-square. All right, here we have two kinds of R-square. These are called pseudo R-square. Okay. It's not exactly R-square, but it's approximate R-square. And I guess that's why they call it pseudo R-square. So one is the Cox and Snell R-square, and that's 0.065, which means, you know, suicide attempts, or about 6% of the suicide attempt can be explained by abuse, okay, which is not a lot. Okay, and then the other one is the Nagel-Kirke R-square. That is always going to be bigger than Cox and Snell. So I guess for that reason, a lot of people would report the Nagel-Kirke R-square rather than the Cox and Snell R-square. Yeah. So like the multiple regression analysis that we learned in the past, we look at R square as one way to judge how good your model is. The other way to determine how good the model is to look at the statistical significance of the model. So this is called really the goodness of fit statistics. Okay. What that is something like this. Okay. If there is no, okay, if there is no differences in the proportion of people or students who commit suicide, okay, let me back up. If there are no differences between the proportion of people who were abused and the proportion of people who attempt suicide, then we have a good fit. In other words, so let's say, so we have these suicide attempt zeros and ones, and then we have abuse zeros and ones. What that is, we will attain a goodness of fit if the proportion of people who commit suicide, okay, is approximately the same proportion as the people who have been sexually abused. Okay, in other words, if if all the people, if everyone, okay, if everyone who commits suicide or attempt suicide are the ones who have been sexually abused, then you actually have a fairly good fit, right?
Sorry, Doc, is that saying then that there's some level of correlation between the two variables because they're similar? Is that what you're saying?
Well, what this is saying, in other words, if okay, let me actually yeah, what this is saying is, if there is no relationship between suicide and and if there is no relationship between suicide and abuse, right? If there is no relationship, then there is a goodness of fit. All right. So think about the chi-square. Think about the chi-square logic of the chi-square, right? In the chi-square relationship, chi-square logic, no relationship suggests that there are no differences between groups, or there are no relationship between dependent and independent variables. Okay, that means there is a fit, there is a there is an agreement in that sense. So let's say so when you have a goodness of fit, let me explain this way. Yeah. So let's say you have 3 brands of cereals. Yeah, let's say you have 3 brands of cereal, brands A, B, and C, and let's say you have 90 people. Yeah. So you have 3 brands of cereals, and you stand, let's say, in the supermarket, and you ask people to taste the 3 types of cereal, and then you ask them which is the best, which in their judgment, which is the best. So, and you ask 90 people. Yeah. So if the 3 brands of cereals are equally good, right? If the 3 brands of cereals are equally good, then you should have 30 people who would say A is good, 30 people who says B is good, and 30 people who says C is good, right? That is what we call as the expected frequencies. That's what you would expect. Okay. Right? If A, B, and C are equally good, then you should have approximately 30 people who says A is good, B is good, C is good. Okay. So let's say then, let's say that you ask the 90 people and you get these distributions. You get 57, 20, all right, that's 77, so that's 13, right? So in this case, we can see that there is no goodness of fit, right? In other words, this observation does not fit this. So when you do a chi-square here, you will get statistically significant results, right? Because the observed doesn't fit the expected. Now, on the other hand, if you get, let's say, 27 here, 28 here, and here is 35, right? You probably would say there is a goodness of fit, meaning this observed fits the hypothesized value. So in this case, if you do a chi-square, you will get a non-statistically significant results, chi-square, which means there is a goodness of fit. All right, so let's apply that to our binary logistic regressions in which we have 2 values. Okay, we have zeros and ones, zeros and ones. Okay. So if there are no differences, okay, if there are no differences in the proportion of people who commit suicide in relationship to the number of people who have been abused, then we have something called a goodness of fit, right? And therefore, our chi-square will not be statistically significant. All right. So this one says we actually have a statistically significant relationship between suicide attempts and sexual abuse. Okay. So the question now is, what's the nature of that differences? Yeah. What's the nature of the differences? So the way to do that then is to look at the result of your binary logistic regressions. So what this is saying is here. So if you look at this, it says sexual abuse is a significant predictor of suicide attempts. All right. Sexual abuse is a predictor, a significant predictor of of suicide attempt. So how do we interpret that? Okay. You look at the odds ratio. Okay. you see that it is 4.77. What does that mean? Okay, what does that mean? 4.77. What that means is that people who attempted suicide, which is one, okay, people who attempted suicide are 4.77 times more likely, okay, to commit suicide. Or, excuse me, people who have attempted suicide are 4.77 times more likely to have been sexually abused. Okay, so how do we know that? So if you look at this, that's a positive, right? That's positive weights. So remember, it is zeros and one, zeros and ones. So the regression weights tell you that there is a positive relationship. Okay, so in other words, more of this is more of this. That's positive. The walls is, you know, the B is positive. That's the regression coefficient is positive. That means there is a positive relationship between suicide and abuse. Okay. So we then have to interpret the odds ratio accordingly. So the odds ratio, since sexual abuse is a significant predictor of suicide, we then interpret the odds ratio as saying that people who have who have attempted suicide are 4.77 times more likely to have been sexually abused. Okay. I suppose another way to do that is you can say people who have been sexually abused, are 4.77 times more likely to attempt suicide. Right. Okay. So this basically means okay, if you belong to this group, okay, you are 4.77 times more likely to be in this group, which is attempted suicide. Okay, so how do we kind of confirm that? So if we go to analyze and go to cross tabs, yeah, and I've done that already here. Click OK. This is what we have. Okay. So if you look at this attempts at suicide, okay, these are people who attempted suicide. You see that 35% of them have been sexually abused versus 10% that have not been sexually abused. Okay. I think, let me see, actually, let me redo this. Might be clearer if we do this. Row. Okay. That would be better. Okay. No, actually. column. All right. So here you see that the proportion of people who attempted suicide that have been abused are approximately 3.5 times, at least in this in these actual observations. All right. But remember, we are doing prediction here, and that's why the odds ratio is slightly more. All right. So much like regression analysis, you run the regression analysis, you look at the equation, you look at how good the equation is. So the logic of interpreting this is exactly the same as you would do in multiple regression analysis. Okay. And that is, you develop the regression analysis, or you begin with a hypothesized model in which you very carefully select predictor variables that would reasonably explain your dependent variables. Okay. So once you have the hypothesized model, you test it with your data. And so the first thing you want to look at is your regression equation. And then you determine how good it is by looking at your R square, by you looking at the statistical significance of the of your model. Okay. The addition to here is, instead of looking at the importance of the variables, okay, you want to look at the odds ratio. I suppose you can look at this and consider that as equivalent to interpreting your standardized regression coefficients. All right. So let's now expand this and say, okay, what if we add more variables? Okay. So instead of just abuse group, what if we add another variable called depression? Depression now is considered as a scaled variable, right? Because remember, that is go from never to all the time. Okay. So here we got sexual abuse as categorical, 2 values, depression as a continuous variable. So if you run this, we have an equations. Okay. This is our regression equations. Okay. It looks like both of these are significant predictors. Okay. How good is this model? Okay. We can look at the R squared. Okay. This is 0.13 or 0.23, depending on which one you look at, the Nagel-Kirke or the Cox and Snell. Okay. A lot of people use the Nagel-Kirke because it appears to be, it looks better. Yeah. All right. So is this model statistically significant? You can look at the this. and you see that it is statistically significant, meaning there are that the two predictors are significant predictors of the dependent variable. Okay. So now let's go and interpret the equations. All right. So both of these are statistically significant. You notice that both are positive coefficients. So that means more of one, more of the other. So here we have the dependent variable is zeros and one, okay, the dependent variable. And then the independent variable is your suicide, zeros and ones. And then depression go from 1 to 5, I believe it is. Okay. So what we have here is we have a mixture. Okay, we have a mixture. Hang on a minute. Okay, let me. Excuse me. So we now have two types of predictors. One is categorical, one is continuous. All right, one is categorical, one is continuous. So so we got this odds ratio that we need to interpret right here. Okay. So now the odds ratio for sexual abuse is 3.493, and for depression it is 2.268. So what do these means? Okay. This one we've already seen earlier. Okay. In other words, people in this group, okay, people in this group are 3.5 times more likely to commit suicide or to attempt suicide. That's what this one means. Okay. In other words, if you have been sexually abused, you are 3.5 times more likely to attempt suicide. All right. Now this one, how do you interpret this one? What that means is this. Okay. For every unit increase in depression, in other words, you go from 1 to 2 or 2 to 3 or 3 to 4 and then 4 to 5, for every unit increase in depression, the odds of attempting suicide is 2.3 times more likely. Okay, in other words, compared to one, okay, compared to one, people at 2, okay, are 2.3 times more likely to attempt suicide. Okay. Or if you are at 4, okay, compared to a person that is at 4, a person who is at 5 is 2.3 times more likely to attempt suicide. So that's how you would interpret the odds ratio for variables that are continuous. Okay. In other words, we now have two variables, two predictor variables. So what that means is that when this is controlled for, in other words, when that is held constant, Okay, when that is held constant, okay, in the context of people who have been abused, okay, in the context of that, people, for every unit increase in depression will result in 2.5 times, 2.3 times more likely, excuse me, to attempt suicide. All right. So that's how you interpret this. So let's add another variable here and add gender. Okay, so we add gender here, and let's run this again. And let's see if gender is a significant predictor. All right, so here it says gender is not a significant predictor. In other words, once you take into abuse and depression, gender does not come into play anymore. Okay. In other words, whatever gender can explain, sexual abuse and depression can explain. But let's look at this. What if we only use gender as a predictor? Okay. So if we had done this, and just take out this and just do gender, would gender predict suicide attempts? So you look at that and it does. Okay. So if we only do gender right here, what this is saying, so gender is so suicide attempt is 0s and 1, and then gender, let's look at how gender is coded. So female, 1 and 2 is female. Okay. 2 is female. So 1 and 2, okay, this is female and this is male. So what this is saying is this: female, since since this is 1, female compared to male is about 1.5 times more likely to attempt suicide. Okay. And an easy way to determine that is if you do a cross tab. So if you go cross tab, okay, so instead of sexual abuse, let's do gender. Here is your cross tab. You have right here, okay, male, female. So clearly you have a larger proportion of female who attempt suicide. Yeah, here it looks like it's about, almost 2 times. Yeah, so 1 point. Okay. But in the binary result, the likelihood in this is right right here. Okay. But once you include suicide and depression, like we have done earlier, gender is not a significant predictor. All right. So this is one of the nature of regression analyses, or in this case, binary logistic regressions. So in the presence of abuse, sexual abuse, and depression, gender is not a significant predictor. All right. Okay. So as you can see, the way you run regression analysis or binary logistic regressions, the logical step is basically the same as regression analyses. The difference being how you interpret. Instead of looking at the standardized regression coefficients or the beta, you now look at the odds ratio. Okay, because that tells you the likelihood of being in the reference group, in this case, the attempted suicide. All right. Okay. I would invite you to read the chapter on binary logistic regressions if you have not done so. And then next week, what I'll do is I will go and I will talk about what I've done today is basically present you the applications. What do each of these means? What's the wall statistics? What's the odds ratio? How is it computed? The other thing we really have not talked about is the classification table. And the other thing that I want to talk about next week is how is binary logistic regressions related to discriminant function analysis. All right, Ian, you have a question.
Yes, Doc. Could I ask that you put the output in a table form for me, please, for us, please. Especially that one with both the depression and the suicide attempt.
Okay.
Just a PA format.
So you want me to save this output and then okay, I can save this and then put it in and then send it to you. Okay.
I would love to see how you would represent all the pertinent aspect, all the pertinent outputs, such as the chi-square, the R-square,
Okay.
the goodness of fit, all of that. So when we would have been presenting our own interpretations, we would represent it as on a table.
Right. So the chapter in your book actually also give you a sample write-up. How do you write the results of your binary logistic regressions? Okay. So what I will do is I will send this output. I will email it to you, and I will also email you the link of the video for tonight's lessons. All right.
And also to Doc, I was just trying to follow it as you go along, but with the data that you said you are using, I realized that you were saying that it should be 0 or 1, but I realized that the data that we have, some of them go from range 1 to 4.
Right.
How would we fix it in order to do the binary regression?
Well, you should know how to do that, don't you?
I was trying. I was trying to fix it to follow along.
So for example, let's say the suicide group right here. All right. So you can transform this variable so that the ones become zeros and these other one becomes 1, right? You know how to do that.
Refresh our memory, Doc, please.
That's going to cost you extra, Carol.
My father is rich in houses and land.
Okay. Remember, so to do that, you go to transform. right? You want to transform, we go to different variables. So suicide, okay. Create a new variable and call it suicide group. Okay. And make sure you click change and you go old and new. So one becomes the never. Remember, since suicide one represents no, no suicide attempt. So make that zeros, representing no suicide. Make sure you click add, and then you go to range 2 to whatever the values are. Make that into ones. Click add, and click continue, and then click OK. And you now have a new variable called suicide group. And make sure that you then label it so that 0 represent no suicide. Click add, and 1 represents suicide. Yeah. All right. So that's how you do that. So you do that for the suicide group, you do that for the sexual abuse group, or you can do that for any other variables that you want to dichotomize. Does that refresh your memory, Carol?
Somewhat, Doc. Thanks
Well,
much.
okay. So you've done that last semester. So, so those are the kinds of things that you really should not forget, because those are skills that you will probably need whenever you need to do data analysis. Okay. All right. Okay, so what I will do is I will save the output. I will email it to you. I will email the link. And you have the value data from last semester. So you can use that to do what we did this evening. So maybe what you want to do is watch the video and then try to replicate what we did this evening. All right. I think it's important that you read the chapter on binary logistic regression, which is chapter 9A and 9B. All right. So I think it's really crucial that you read those chapters ahead of time, because I will not be able to teach everything that is in the textbook. I'm just essentially facilitating learning. In other words, I'm just going to present to you the highlights of the topic, and to some extent, it's really up to you to learn the other aspects of it. Right. Okay. That's it for this evening. So next week, make sure you read the chapters, try to do the exercise that we did this evening, watch the video. So clearly it requires that you invest time for this class, right? Also, those of you who don't have SPSS working yet, make sure you get them. If you have difficulty, consult with Sally, because she has been able to download her stuff successfully.